after constructing more circle for strain, and we find epsilon 1 473 micro, epsilon 2 negative 59 micro, and gamma max over 2 equal to 266 micro. From the Morse circle, we can go back to the process flowchart here. We are in that state that already have epsilon 1, epsilon 2, and gamma max. The next step is we use generalized Hooke's law so that we can find out the final output. And the generalized Hooke's law, it will be the principal stresses sigma 1, sigma 2 in here. And we can also find out the tau xy, as you can see, equal to chi over gamma xy. So it's tau max equal to chi gamma max. So all of that we already have. And with that this equation, we can be able to find out the principal stresses and maximum in plane set stresses. So let's continue with worksheet 12b. So let's write from more circle for strain as we did, then we can be able to find out epsilon 1 equal to 473 micro inch over inch, epsilon 2 negative 59 micro, so it means 10 power negative 6 over inch, and gamma max over 2 is 266. So we have that is gamma max equal to 266 times 2. That equal to 266 times 2. We have 532 micro inch over inch. So we have all of that from the Morse circle. Then we apply the generalized Hooke's law. So we can employ general Hooke's law to find out the principal stresses and maximum in-plane shear stresses. So principal stresses sigma 1 equal to equation shown earlier that you can see here. So we can go back, E over 1 plus go nu 1 over nu square, 1 minus nu square, and then you have epsilon 1 plus nu times epsilon 2. Plug in E for you see A36 still the problem given, otherwise go to appendix B. E 29,000 KSI, nu 0.32, and chi 11,000. So we can go back here, we plug in the number that we have, 29,000, 1 minus 0.32 square, epsilon 1 473 plus 0.33 for nu time negative 59, and as you can see that in micro, so everything else it have to time with 10 negative power 6 because that is the micro epsilon all in micro, right? Negative 26. With that equation, we can find out sigma 1 equal to 14,671,881, and time 10 negative 6 KSI. And streamline, as you can see that it sigma 1 it equal to 14.67 KSI. That is the first answer. And of course, just keep continue. We can find out sigma 2 with equation flip. Epsilon 1 become epsilon 2 and vice versa. So you have E 1 minus mu square epsilon 2 plus mu epsilon 1. Plug in 29,000 1 plus 0.32 square negative 59 epsilon 2 plus 0.33 times 473, and of course we have to time 10 power negative 6 because that is the micro. Inch over inch, micro is 10 power negative 6. So from that we can have sigma 2 equal to 2,984,001 times 10 power negative 6 KSI. And with that we have sigma 2 equal to 2.98 KSI. That is the second principal stress from the question. And the question also asks the maximum in-plane shear stress. Even in your handout, we don't have the equation for tau max, but it actually we can apply here. Tau xy equal to chi gamma xy. So tau max equal to chi gamma max. That's it. So we can go back here. We have tau max equal to chi gamma max. And chi at the problem given for the A36 steel or appendix B, we have 11,000 KSI. So plug in 11,000 KSI time gamma max 532 micro, 532 micro, which is times 10 power negative 6. So what do you get here? 11,000 times 532. You will get 5,852,000. So you will have it 5,852,000 times 10 power 6 KSI. So you have tau max equal to 5.85 KSI. And that is the maximum in-plane shear stress. And with that, we're done for this long problem, 13B. As you can see there. Okay, so we're done for this one. Move on to worksheet 13